What's the one type of code that we write the most, but also struggle with the most in JavaScript and TypeScript? Asynchronous code. So on this blue collar coder, we are going to take an in-depth look at async and turn it from a weakness into a strength. Of course, at any point, if you have any questions or comments, be sure to put those in the comment section down below. If you like the video, hit that like button. If you really like the video, hit that subscribe button. Let's jump back into the office and dive deep into async code. All right, so let's go and create a new project called Async with TS. And then we'll bring it up in VS Code. And then within that, I am going to create a directory called Node.js. And within that directory, I'm just going to do yarn init -y, and I'll add TypeScript, as well as TS node and the types for node fetch, which is what we're going to be using to make our async calls in development mode. And then I'm also going to add node fetch, so we have something to make some calls with, because that's the kind of thing that you normally do with async stuff, is make calls and get events. And then I'm also going to do tsc init, which is going to create a ts config in this directory. And looks pretty good so far. Okay, so let's go and create a new file called index.ts, and we'll start making some requests. So let's go over here to index.ts, and we'll bring in fetch from node fetch. So we'll use fetch to go get something. So why are we doing that? Well, that's asynchronous. So fetch is asynchronous, and we do a lot of async work with services. So what are we going to do? Well, we're going to call localhost API v2 Pokemon. This is actually the same as the pokeapi.co one. So if you were to go and change this to pokeapi.co, this would work just fine, get exactly the same values. I'm just running it locally because it's more predictable when you do a video like this. You don't want to mess up. So I'm just going to grab that and put that in here. Let's go take a look again at what this is. We got the count, next, previous, results, and all that, as well as the names of all the Pokemon, which is awesome. So if you want to go and run it locally yourself, I've included a link in the description to the Poke API project. It's absolutely, open source in GitHub, and you can just go down to Docker and Compose, which is the way that I did it, and follow this, and it works fine, just right out of the box. So really good. Let's go over into VS Code and see how we're doing this. So fetch returns a promise. And there's three things that you can do with a promise. You can do then, catch, and finally. So we're going to do then. So we're going to go through the happy path first. And the first thing you need to do when you get back a response is to go and get the JSON out of that payload. So that's how you do that. And take the response, which comes in as an argument, and then from there, do .json to get the JSON payload out of it. And then from there, we're going to do then again and get the data. And we'll just console log that. Now let's go back over here to our terminal, do npx ts node, and do index.ts. And we get a whole bunch of data. Super cool. All right, so how is this data defined? Because we want to do this in TypeScript. So it's got this count, previous. I've actually already done this interface, so let me go and bring that in and paste it in here. And now I can take that Pokemon list, and I can say that the data coming in here is a Pokemon list. And from there, I can do, for example, something like along the lines of data.results, because now all hinted and all that. And we'll get the URL for the first Pokemon. So go back into our terminal and then run this again. And cool. Now we're getting this. So what does this look like? Well, if I click on that, then I can see that this has a whole bunch of detailed information about a Bulbasaur, the experience. So I go all the way down here. It's got a section on stats that we can take a look at. So what if I want to go and have one response that then informs the next request that I make? So I want to go and actually make a subsequent request of this particular URL. So how do I do that? Well, if I'm using this then system, what I need to do is go here. And within the then essentially I'll copy and paste this, paste that in there, and I'll just use this URL, drop it in there, and away you go. Of course, I'm not getting back a Pokemon list at this point. I'm getting back a Pokemon, which I haven't yet spec'd out. So we'll just go and console log out the stats from that as an example. All right, so there you go. Pretty cool. You're getting all the stats now. So we're making one request, and then that request is then informing the next request that we make. Okay, so that's the happy path. So how do I catch if there's an issue? Like for example, if I do here 5050 as the port number, that doesn't exist. So this is going to blow up. So what happens then? So if I run this now I get this unhandled promise rejection. So this promise blew up. It threw a rejection and we didn't catch it. So how do we catch that? Well, we put in a .catch. And then you get an error back. And then we can then just console.error out that error. We can do whatever we want with it. You know, obviously, I think we're just going to go and console.log that out now. And now at least, now we control the error. We can say, okay, we made this request, we failed, and we can do whatever logic that we need to do to kind of compensate for that error. But what happens if I have that as a nested error, like this one down here, this fetch blows up? So does that actually get caught by this catch down here? Well, let's go see. So I'll go and copy this, get rid of the 5050, go over here, pop that in there because we know that's going to fail. Now let's see what happens. Okay, so that threw then, again, it didn't get handled, it got rejected within here, and it didn't get picked up by that secondary catch that we have. So you need to go and catch this one as well. And so this is getting kind of to be kind of a pain in the butt here, right? You've got multiple nested functions. If you had like a whole stream of these, you're going to get a whole kind of cascade of this, and this is just not a particularly pleasant way to work. So what's an alternative? Well, the alternative is to use async await. So let's go and convert this code now to async await code. So I'm going to go and take this and copy it into here, get rid of the catch, like that. And the first thing I need to do is, let's say we're going to get a list response. And that's going to be the result of an await of fetch. Now, await expects that you get given a promise, fetch returns a promise, and it's going to essentially block to some degree on that promise. So that's going to give us back the response. And then from there, we're going to get the list, which is a Pokemon list, by awaiting the list response.json. .json in this case is also a promise. You have to wait for the body, and then you got to go parse it. So it too is asynchronous. And then we've got our list. That's a lot cleaner, right? You know, you don't have a lot of functions in there. Kind of empirically makes sense. So let's do the same thing down here with this fetch. In this case, we'll call this a data response. And again, we'll await it, and we'll go and fix it so we're not calling that bad URL there. Cool. And now we'll go and get the data. We don't have Pokemon defined yet, so let's get rid of that. That's GitHub Copilot that's going and hinting a lot. It's actually very helpful. I'm a terrible typist, so that helps out a lot. Okay, so this should work, right? Okay, actually, hold on. We need data and list right there. But we're getting these red underlines. I wonder what that's about. Let's hit save and then try and run this and see what the deal is. So this is telling us that these await expressions cannot be at the top level of our file. We actually have to have them within an async function. So that's actually going to change, but right now that's the case. So I'm going to go first create an async function and then take my code and drop it within there. Cool. And now I've got to invoke this function somehow. So I'm just going to wrap this in a parentheses that turns it into an expression and then call that expression. Now let's run it. And it works. Cool. We're getting our stats. How awesome is that? Super easy. Now, how do we handle errors in this case? Well, in this case, it's actually a lot easier with async await. All we need to do is wrap it in a try catch. So let's console error out that error if we have one. All right, looking pretty good. Let's run it again. No errors, looks good, but let's make it have an error. And there you go. Now it's caught by that try catch, and we're controlling the error at that point. If we do the same thing down on that secondary request, do we also get trapped? Let's try it out. Yep, we also get trapped there too. So just a much nicer development experience and a much cleaner way to make more predictable code, more reliable code, where you've caught all of the potential error vectors. All right, so let's get back to something working. So let's go turn this code into something a bit more modular by extracting this request into its own function. So we're going to create a new function called getPokemonList that returns this. And the way that you specify that you get a promise back is you do promise and then whatever the data type is you're returning as the interior of the generic expression like that. So in this case, it's a promise, it's returning a Pokemon list. Of course, it's not quite doing that at the moment, so let's go and return that. And now it's working just fine. You can see there's no more red underline because we're returning the await of that list response.json. So let's go make a call on that. Call that list equals await, and then we'll do the get Pokemon list. And we'll give it a try. And it works just fine. Cool. So now you know how to return a promise as part of the definition of a function. So let's do the same thing for this code to make a get Pokemon function that returns a Pokemon. So first we have to define a Pokemon. Now all I really care about is the stats. So I'll make a very simple Pokemon structure here that has the ID, the number, and the stats. And then we'll go and take this code and create a new get Pokemon that when given a URL returns a promise to give you back some Pokemon. Put in that URL into the fetch and then return that out as well. There you go, get Pokemon all done up. So let's try that out and we'll do Pokemon equals await. Yeah, that's pretty good. Await the get Pokemon list results URL. There you go. Good, good, good. Okay, so let's go and then just console log out the stats again. Or just let's try something else like the name. Bulbasaur. Nice. All right, perfect. So now we know how to use a promise with fetch, but how do we actually create a promise if we want to create one on our own? Let's go and create a new function called getFirstPokemon that basically does this. And it's going to return an async promise to a new Pokemon. Now, the way we start that is to do new promise, and the constructor for promise takes a function that gets given two values, resolve and reject. Now, resolve is a function that you give it the data, and you resolve the promise. You say, I'm done, I'm good, and then if you run into an error, you reject. So let's go at this point and say that in this case, we're going to resolve the result of this await. So that is the first Pokemon. Very cool. But how do we use this reject one? Well, we can use that try catch that we did. And if we run into an error, then we just reject with that error. Now, of course, we need to make this an async function so we can use our await in there. And it looks good. So let's do the get first Pokemon and see how we do. Nice. Awesome. So now you know how to create your own promises if you want to make a promise-based function. Okay, so now I'm going to bake your noodle a little bit. I'm going to go and create a console login here that says getting the list. All right, and we will do a npxts node, and we can see that we're getting the list, and then we're returning Bulbasaur. Makes sense, right? So I go down here, and I say that that's my Pokemon promise, and then I await the Pokemon promise to get the Pokemon. Does that work as well? Let's try it out. Yep, that works too. So if I copy and paste this, and I make Pokemon 2, and it awaits the exact same promise, question is it actually going to get the list twice? So I encourage you to pause the video, have a think about this for a second, and then restart the video and see what actually happens. Okay, so let's assume that you did that. Now let's run it again. So it only gets the list once. And that's the really interesting thing about promises. Let's go have a look at the page on promises. And you can see that a promise is in one of three states. There's a pending state, there's a fulfilled state, which means that you've gotten the data, and there's a rejected state, meaning there was an error, as we saw with a reject. So in this case, what's happening is that promise has already been fulfilled, meaning that if I go and await it again, I just immediately get back the results without having to go and do the promise again. So it's really cool. A promise is effectively both a way to manage async, but also a cache. Think about it. If you've got multiple places in your code that want this first Pokemon, and you have one promise, then that one promise will handle essentially the cache of managing that first Pokemon anywhere that you use it. So that's actually really important, and it's something actually I didn't know first off about promises, and it's really cool. It's a great way to kind of pare down your code because you don't have to look around and say, well, hey, have I gotten this? If so, go get it, set a cache, manage a cache on your own. None of that. It's really great. Okay, so let's go and see how to go and do a bulk request. So let's say I want to go and get every single Pokemon in the Pokemon list. So let's go back over here and first get our list of Pokemon. And then we're just going to go through that list and get to the results and then do a for each. And then within that, we're just going to go and get some data. Let's see. So let's get the Pokemon by awaiting get Pokemon. And we'll take that list item. And we got to make this an async function, right? So we can have a wait in there. Looks good. And then we'll console.log out the Pokemon name. Okay, good. Well, let's try it. So we should get a list of 20 Pokemon. Oh, wait, whoa, what? Okay, hold on. All right. So here's what happened. Eventually, we ended up running out of requests, effectively. We can't handle that many requests simultaneously. There's 20 in that list, and we made 20 simultaneous requests. And that's because for each actually is incompatible with async await. It doesn't block on all of that. So we did get a bunch of ones that actually worked, but we had a bunch of ones that failed. Now what we can do is we can slice this down. We could say we only want the first 10. Let's see if that works. And yeah, that reliably works. So there is this inflection point where you can make too many requests. So what's a way to do this safely and sequentially like we want? Well, the easiest way to do it is with a for loop, because a for loop is actually compatible with async await. So let's try that out. So let's do, in this case, for, and we'll do list item of list results. We'll just drop that in here. Now we'll run it again. And now it's going sequentially, boom, 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 all the way down that line of 20 to go and get all of our data. So how long did that take? Well, let's do a time on that. All right, it takes about 7 seconds in total. All right, not bad. But before we go into how to make that more efficient, let's actually talk a little bit about an interesting pattern that some people use when it comes to making these requests sequentially like this, and that's to use reduce. So I'm going to go and comment this out for a second. And I'll use reduce in this case. And there's two values that get sent to reduce. The first is the previous value and then the current value. So in this case, the previous value is going to be a promise. And the new value is going to be a Pokemon, because it's one of the list of Pokemon results. So let's go in there. And what we're going to do is we're going to await that promise. So this needs to be an async function. And then we're going to return a get Pokemon with that Pokemon URL. So that's going to be the promise that then feeds back into itself. So how do you actually start this? Well, you can use a static method on promise called resolve. And that returns a resolved promise, a pre-resolved promise. So let's do undefined in there. And then Typescript is having some issues with this. So let's define this as a promise unknown. So we don't really know what the promise is going to be, but that's what this value is an unknown promise. All right, so let's do this again. So it takes about the same amount of time, about 7 seconds. But we really haven't seen any output of this. So let's go and add on an additional then, and that's going to give us our Pokemon. And we'll just console log out that name. And now we can see it's sequentially going through and getting all this. This is an interesting pattern. I've seen this a lot. I think this is really tricky. But when you've got something as nice as 4 that actually works, I don't really see any particular value in doing this kind of more complex reduce. I just wanted to show it to you because I've actually seen this in code before. It looks really cool, but it's a little bit hard to track. But it does do a sequential review and execution of all these different promises. All right. Okay, so let's try another attempt at doing this. I'm going to use something called Promise.all. And so the first thing I need is a list of promises. So I'm going to go through all those results and do a map. And that's going to have the Pokemon. And with that, we're going to get the Pokemon and then do Pokemon.url. And that's going to give me back a bunch of promises. And then I can execute them all with Promise.all. And I'll put a little console.log down here that says we are done. All right, so let's try this out. Okay, so interestingly, immediately we get a done, which means that we're not blocking at all on this promise. And also we get the unhandled promise rejection, which means, again, we're making too many simultaneous requests. So let's go and do the slice to get it so that we are not doing that. We're just getting the top 5 or so. Okay, so we're getting done, but we really don't know when that happened. Okay, so let's see what we get out of this. We get a promise for some data, so let's do an await on that. All right, looks like we get back all of the data of the top 5. That's not bad. Okay, so we've looked at a way to get sequentially a bunch of Pokemon data, and we looked at a way of simultaneously making a bunch of requests, which can actually overflow to go get all of the Pokemon. So is there a way that we can go and, say, get 5 Pokemon at a time? Well, yeah, there is. It's called promise pooling. So we're going to bring in a package called Promise Pool from Supercharge. What it allows you to do is create a pool of promise with a certain number of slots. And then as one promise fulfills, if there's new promises to be added, it goes and manages all that for you. It's actually really nice. So let's go and bring this into our project. And then go and copy out some of this code. So we need our promise pool, so we got to go get that. So let's go back up to the top and import it. Okay, so I've got our list, and that's the list.results. And we have our process in here. So in this case, we got our data. So if I do Command K, Command I here, we see that it understands that this is the name and URL. So I'm going to go over here and do an await on get Pokemon and give it the URL. And I'm just going to return that. And now let's go and print out all the names that we got back. So let's do a console.log of the results, and then we'll map through those and we'll get their name. All right, let's try it. Very cool. We get back all the names, and we get it in about 4.8 seconds, which is better than the 7 seconds that we had before. But we can actually just kind of toggle the concurrency here. So let's take it all the way up to 10 and see how we do. We can have 10 concurrent connections and still work. And that takes us down to about 3 seconds. So we have 10 simultaneous connections going out, getting Pokemon data. So we're not overflowing our ability to manage connections, but we're also getting data a whole lot faster, which is great. Okay, so this is great and all, but we need to make testable code. So let's go and refactor our project a little bit so that we can actually test it using Jest. So we'll go and take out all this code and create a new file in a new directory called source get Pokemon.ts. Paste that all in there. And now we're just going to export a lot of this. Bring that over here, and now we can do get Pokemon list and get Pokemon from source, get Pokemon. Okay, let's make sure it still works. Cool, nice. All right, it's getting us back our 20 Pokemon. So let's go and create some tests for getPokemon.ts. First thing I'm going to do is add in tsJest as well as jest in debug mode. And then because we're in TypeScript, I want to add the types for jest, also in development mode. Cool. And we'll go over here in our package. We'll create a script, which would have a test, which is going to call jest. And then over here in source, we're going to create getPokemon.test.ts. All right, cool. And now we need to describe that we are going to be testing getPokemon. And we need to import getPokemon list, I would say. Let's try that first. And here we're going to do it should get a list, right? We're going to go test that getPokemon gets a list. So should get list. And we have a function. And now we're going to go and do getPokemon list. We're going to get that list back. And we expect, let's see, well, list be defined. That's not bad. We could just say, for example, list.results0.name is going to be Bulbasaur. How about that? And let's go in here and also do console.log and say actually running test. Just got to make sure, right? Never too trusting. And the last thing we need to do before we run our test is to do npx and then tsJest and then config init. We need to configure all of our setup so that it understands how to do everything. Now let's run that test. Okay, so it is running, and that's cool, but it says they cannot log tests after they are done, which is interesting. So what's happening here is an async problem. This function is actually dropping out and getting done before this value comes back. So if we wanted to keep with the then syntax here, then what we could do is we could add a done onto this. And when Jest detects that you actually are taking an argument, like done here, it will wait for the done to be called to say that the test is completed. So in this case, I just want to do done at the end. And let's see how we do. All right, great. Ran test pass, that's awesome. But, if you don't want to use the then here, can we just do an async? Sure we can. So let's go and get rid of the done, make this an async function. So that we're getting the list, like that. Let's give this another try. And it runs just fine. Awesome. Okay, so asynchronous test in Jest, not a problem, but there are some little gotchas in there. You can either use that done, or you can define the function as async and manage that yourself. Okay, so now that we got great tested code, can we do it in something other than Node.js? Sure, we can go and do it in Create React App. So let's go and make ourselves a Create React App and bring in our code and see if we can get the Pokemon working in there as well using pretty much exactly the same code. So let's try it out. Close a bunch of these windows. I'm going to go back to directory, and then I'm going to do yarn create React App, call it promises, and we'll make sure that the template is TypeScript. All right, let's jump into promises. We can get it running, and then we'll go and start hacking this down a little bit. So our app.tsx file, we can get rid of a lot in there. And I'm going to go and grab this getPokemon.ts. I'm going to just copy it in to this project. Now, you don't need node fetch. You just have fetch inherently in the client environment, so that's great. And from React, we're going to need some stuff. We're going to need use effect and use state, because we're going to need to store our Pokemon somewhere. All right, let's go back over here to our test file, and we'll bring in Promise.all and also get Pokemon list. Paste those in there. Cool. Now we need to bring in this Promise.all. And then let's go back over here while that's working, and we'll go and get our Pokemon list, and then get all of our Pokemon and all our results. Yeah, cool. All right. In fact, actually, we'll take all of that. Now over in here, so if you want something to run when the component first loads, you need a use effect. And that takes a function. And a dependency array, if you leave the dependency array as an empty array, it will run only once. And I'm going to paste in here the code that we have from before. Now, this isn't an async function, and useEffect doesn't allow for async functions. So what we need to do is create a new function in here, an async function, and we'll call it getData. And we'll paste our code into that. And then we'll run that first thing, so getData, just like that. All right, looking pretty good. Let's start it up and see how we go. Okay, now this shows a blank page because it got rid of everything, but if I go over here to the inspector and look in the console, you can see that we now have an array of 20 with all of the stuff that we had from before. So all of that promise pooling is actually working. Let's go over to the network tab and see if it actually works. Check that out. Look at all those Pokemon we got. And we got it in a really controlled way. That's great. So we made one request that got us the list of Pokemon, and then we made 20 subsequent requests that got us all the data for the Pokemon. That is so cool. Okay, so let's go and bring in Pokemon as the type, because we're going to go and store this in some state. So let's create some state. List of Pokemon. There you go. That's not bad. So now we'll set our Pokemon to this. And we don't even need to, there you go, that looks good. And now let's just iterate through all those Pokemon and put them on the screen. Cool. Let's see, an li with the key of the Pokemon name or the Pokemon ID. And then interior as the Pokemon name. Not bad. Cool, and then we need to wrap that in a unordered list. All right, let's check it out. Hey, wow, that's nice. All right. Interestingly, it comes up in a different order every time because those are actually coming in out of order. So you might want to go then and sort it. That's just the nature of the async. Some results return faster than other results. Okay, so the last thing I want to talk about in this video is callbacks. There's actually 3 different ways of doing async code in TypeScript and JavaScript, and that's callbacks, promises, and then promises using async await. We've talked a lot about promises and promises using async await. We haven't talked at all about callbacks. I'm going to show you 2 different things here. The first is how to make a function that has a callback and how to call that. And then the second is how to use a somewhat unknown feature of TypeScript called function overloading. It's really kind of neat. So let's go and go back into our Node CLI project, and I'll create a new file in here and call it Callbacks. And I'm just going to go and grab the Pokemon list and fetch. And we'll go and get Pokemon list, and we'll turn it into essentially a callback function. So a callback function returns a void, and it takes as an argument a callback, which is a function that by convention takes an error or undefined as the first value, and then whatever the data is as the second value. So the first thing I need to do is then get the JSON, and then another then, and now I've got my data, which is a Pokemon list. And then with that, I want to call that callback with that data. So there's no error, it's undefined, that's great, and you get the data as well. So that's the contract there. And then if I blow out, then I want to catch, and I want to get that error, and then I want to go and send off undefined as the data. So this also needs to be Pokemon list or undefined. All right, so how do I call this? Well, I call get Pokemon list, and then I give it a function. And that takes an error as well as the data. So what can we do with that? Well, let's just console log out that data. All right, let's go back over into our Node.js project, and then we'll do TS Node, but in this case, we'll do that callbacks. Yeah, there you go. Okay, so the reason people don't like callbacks necessarily is that you kind of get into that same cascade. So for example, if you've got get Pokemon list here, it may then you want to go and do the same thing we did before where we get multiple Pokemon and you get this kind of cascade of functions, calling functions, calling functions. And it gets gnarly, which is why people like promises and why people really like async await. So how do we actually go and give people the choice? Say, for example, if you provide a callback, then we'll do the callback thing. If you don't provide a callback, then we will give you a promise. Well, we can do that, and we can actually make the signature quite elegant by using function overloading in TypeScript. So first thing I need to do is just change this to a function. And then we're going to define multiple signatures above this, and this implementation function needs to handle all of those different signatures. So let's start off with, this is a signature for a callback. But if we don't have that, then we have no callback, and we get a promise to return a Pokemon list. So that's our second function signature. Okay, so now the return value here is bad, so we're going to make it a promise or a void depending on whether you've got a callback, and we can make the callback optional. So in this case, if it's a callback, then we're going to do what we did here. Not bad. And if we don't have a callback, then that means we want to return a promise. So we're going to return a fetch like this. And the last thing to do here would be to return undefined, which is essentially void. Okay, let's try this out. Okay, so now the callback still works just fine. And let's just return, for example, the results length. That's going to be a little bit quicker. And then let's go make another function, an async function, so we can use the promise variant. So let's go and get that list. And then we'll console log out the results. Let's see. Okay. Looks awesome. 2020. All right, great. So what have we learned here? Well, we learned that we can use this function overloading paradigm to give folks an option between a callback interface, if you still want to support something like that, and a promise interface if you don't specify a callback. And you get elegant hinting when people ask for the various signatures. They get given a list of, hey, you can either do the callback variant or you can do the promise variant. It's really up to you. It depends on whether you pass in a callback or not. So that's function overloading in TypeScript as applied to callbacks and promises. All right, well, I hope you enjoyed this exploration of async code in JavaScript and TypeScript, and it's turned a weakness of yours into a strength. Of course, if it has, hit that like button. And if you have any questions or comments, be sure to hit the comments section down below and ask me any questions. I always love that. And of course, YouTube loves that as well. And of course, I would always love one of your subscribes. All right, I'll see you on the next Blue Collar Coder. Always sounds so cheesy. I'll see you on the next Blue Collar Coder. Next bat time, next bat channel. Same bat channel. Same bat channel.